Hey guys, Mr. Browning here to talk to you guys about the acceleration unit and the vocab within. So first I'm going to start off with the challenge connection. You guys know that we're doing the egg drop, um, and you have pretty much this unit, the next unit, and then you have a full week to conduct the egg drop, and the instructions will be coming pretty soon for that. Okay, so in this unit, you're going to be learning about acceleration, and for the egg drop, you're going to have to know how to actually calculate acceleration, know what it is, especially in terms of gravity, and its relationship with forces and pressure. Okay, so what happens when an object is accelerated quickly, like it hits the ground? Um, why do you need to put a bunch of cotton balls inside your capsule? Pretty much is what you're learning how to explain pretty soon here, or you're taking a step in that direction. All right. Um, so this, again, very similar to the last section, is a stepping stone to actually understanding a lot of the major concepts. Okay. In addition to that, acceleration is going to be used in the next challenge. Okay. Um, and the next challenge is going to be you building trebuchets. Um, so success criteria, again, the vocabulary is first. All right. 5 other pieces of vocabulary, 5 and 6, are pretty much just labs and IB labs. For my regular students, you don't have to worry about success criteria 6. That is honors class only. Alright, so this unit is comprised of mostly only content-based vocabulary and not skills-based vocabulary. So we have acceleration, and acceleration is change in velocity. There's no easier way to put it. Acceleration can be positive, it can be negative, it can be a change in direction. Okay. If we are talking about a car, all right, we usually say an accelerator and a brake, or the gas and the brake. They're both accelerators, okay? It's just that the brake is a negative accelerator and the gas is a positive accelerator, okay? Now, one of the biggest misunderstandings is how we measure acceleration, or the unit used to measure acceleration. So acceleration, again, it's that change in velocity over time. Now, the goofy thing about it is that velocity is already meters per second. Okay? Now, acceleration is the change in this meters per second. Okay? Per time. So let's say that someone goes from 0 to 60 meters per second. So again, this is their velocity. So they go from 0 meters per second to 60 meters per second. And they do this in a time of, let's say, 6 seconds. Alright, now we have a whole bunch of weird gobbledygook here, talking about seconds here and there and everywhere. Alright, so first of all, acceleration is measured in meters per second per second. Okay? Now another way to say this is meters per second squared. A lot of students want to do is they want to square it, or they want to do some fancy weird math stuff with it. You don't have to do any type of squaring. Okay? In this case, you go from 0 to 60. Okay, so you look at the change in velocity. So how much did it change if it went from 0 to 60? We know that it changed by 60 meters per second. Okay, and it did that in 6 seconds. So what we would say is 60 divided by 6 is 10 meters per second each second. So we give it a square. Okay, so 10 meters per second per second. All right, velocity v time graph, acceleration v time graph. You're going to be seeing a lot of this in the Physics Talk 1 and 2, especially the 2. I think the end of the 2 has like 9 graphs for velocity time, acceleration time. But velocity time graph, what it's going to show you is an object or a person's velocity over the given time. You guys should be familiar with the distance time graph. Now, the velocity time graph is derived from that. Okay, just like the acceleration time graph is then derived from the velocity time graph. Now, a slope in a distance time graph, so thinking back to the first unit, distance time graph, a slope means that something is moving. It's changing its distance. All right, now, velocity time graph, all right, if it has a flat line, it could still be changing distance. It could still be moving because velocity, if it stays constant at 5 meters per second, let's say, the object is still moving. But if there is a slope in this line, then that means acceleration is occurring. If the slope is going down, then we know that there's negative acceleration. If the slope is going up, there's positive acceleration. Then the acceleration v time graph. Now with this one, this is going to show change in acceleration. So if there is a positive line, so let's say the line is at 2, then that means that the object is accelerating. It's increasing its velocity or decreasing its velocity. And a value of 0 on an acceleration versus time graph means that velocity is maintaining or keeps staying the same. Okay, now ticker tape timer. This is a pretty cool little device that you guys are going to be using. It's just an easy way to visually represent acceleration and velocity because it's going to show you distance between different dots. Okay, it's showing you pretty much where the paper was at a given time. The faster you move that paper, the further those dots are going to be away from each other. This is very, very similar to the idea of distance and time. Okay, the further the distance is, okay, just like in velocity, the longer the distance, the faster it's going. Now, if that distance is increasing between those dots, then we know that there is acceleration. Alright, now I think that is it for this video, nice and short. If you guys have any questions, let me know. Other than that, see you guys next time.